up, guys? Yeah, welcome back, man. Welcome back to 5-Minute Math. Welcome back to Herbs class. Man, let's get to it. It's another geometry lesson today. Today it's about spheres. Oh yeah, you know what a sphere is? A sphere is like a 3D circle. Think of like a basketball. I mean, you can think of something else, but why wouldn't you think of a basketball? Think of a basketball. A sphere is a basketball. So it looks like this. Yeah, something like that. A basketball has got a couple more lines on it or whatever, but you get the idea. So if a sphere is a three-dimensional ball, then there's a certain space inside that sphere, right? That's called the volume, of course. The space inside that sphere is the volume. And there's a really easy formula to find the volume of a sphere. Looks like this. Yeah, yes, that's exactly right. That's exactly right. So the volume of a sphere, 4/3. Now, however you want to work that out, if you want to turn it into a decimal, it's between you and your teacher. But 4/3 pi times r to the third power. Yeah, if I wanted to fill this sphere up with some air or some sort of liquid or something like that, or if I had a metal ball and I wanted to know the volume of that metal ball, that's the formula I would use. Yeah, exactly right. So after volume, we usually talk about what's called surface area. So what if I wanted to paint the outside of the sphere? How much area is around the outside of the sphere? There's a formula for that too. It's like this. Yeah, that's how you find the surface area or the outside portion of the sphere. Exactly right. Now this gets really interesting though when I do this. Yeah, happens when I cut half of the sphere off. You know what half of the sphere is called? We got them on Earth. Yeah, a hemisphere. And you would think, right, that if you cut a hemisphere or cut a sphere in half, then couldn't you just cut the surface area in half, right? Like that, right? And then, you know, it would really be like, right? No. When you cut that sphere in half, you created a new space, right? Think about if I had an orange and I cut that orange in half. The surface sphere, the surface area of the whole orange was around the outside of the orange. You know, we didn't have this before I cut it. So when I cut that orange in half, this surface area is just half of the curve on the outside. So think about it like this. Exactly right. So that's the surface area of just the curved part. But what about this new, maybe we could call it a base, but what shape is that? Yeah, it's a circle. So if I wanted the total surface area of this hemisphere, including the flat part, it would look like this. Yeah. So when you think about a hemisphere and we're talking surface area, there are two parts to it. So we have the curved part that has a surface area of this 2 pi r squared. And then don't forget we have the new base that we created where we chopped that bad boy in half. Yeah, and that's also a circle, and we have to add that in if we're talking about the total surface area of the whole hemisphere. But you know what? Don't those look like like terms? If I have 2 pi r squareds and I add a pi r squared, wouldn't that just be 3 pi r squared? Now, remember, that's for the total surface area of the hemisphere, including the base. If you just want the surface area for the curved part, 2 pi r squared, half of 4 pi r squared, which was the total surface area of the sphere. Yeah! Oh my goodness, man. Thanks for checking me out. I hope this helps. I'll see you next time. Bye, guys.